Hi, welcome to another Q&A series. In this series of videos, what I do is answer PSLE science questions that my students ask me. Now, there could be also P5 students who ask me questions. I will respond to those as well. So if you have any questions, just drop me an email and I will do my best to respond to you as soon as I can. Object X that weighs 500 grams is pulled down the ramp with a spring balance. Alright? The experiment is then repeated by pulling object X up the ramp using the same spring balance. So the spring balance will register the force, alright? And what force is that? Of course, if you are pulling it, it's a pulling force. But the pulling force, if you can overcome the frictional force here, that will represent the amount of frictional force if it's on a flat surface. Now, if it's an inclined plane, then you've got to factor in gravitational force. Right, pulling up, of course, then there'll be the frictional force that this up, you see, if there's a pulling force here, this pulling force has to be greater in order to move this object, right? This pulling force must be greater than, number one, the frictional force here, and number two, the gravitational force here that's pulling it downwards. Okay, so you got to be greater than these two. Now, if it's pulling it downwards, alright, then of course you notice that there will be less force here because it's like you running downhill, right? Gravitational force is already pulling you down. Okay, of course you must overcome frictional force right now, but there are two forces here, so naturally there would be less here in terms of the pulling force, and that will be registered here as a smaller value compared to here as a bigger value on the spring balance. So direction of object X down the ramp, if it takes 300 grams, okay, so that is like the equivalent amount of force. Remember we talked about weight before? Weight represents gravitational force acting on the object, on any object. Okay, the weight of an object represents a gravitational force that's acting on it. That is why an object in space floating around has no weight, because there isn't any gravitational force acting on it. So if it's up the ramp, as we just discovered, it should be more than 300. So here, any figure that is greater than 300 would be correct. For me, I may just put 350 because I do not know. Alright, I want to go and put 1000. Alright, I just put a figure like this. I'm not sure what answer is given by my student here. I can't really see it. Alright, but she gave a tick, so yeah, I'm not quite sure what's the digit in front. Okay, so this is a soft copy of the same question. From what I can see here, I think she wrote down 400, which is definitely greater than 300, and that's correct. Definitely, no problem with that. Now, of course, if you want to send me questions, I will also suggest that you send me questions with your answers written in pen. That makes it much easier for me when I print it out. Let's go back to this. Explain why the reading on the spring balance when object X is pulled up the ramp is different from object X when it's pulled down the ramp. Now, I already just explained to you verbally how that's done, right? So every answer question, you got to know what is the concept behind it. I'm not addressing the question that my student asked me, can we answer by using energy, alright? First, you must know the concept that this question is based on. Because in every question that a teacher designed for you, or for the students, or for the test, they are looking to test if students have understood a certain science concept. If the concept is about forces, they will phrase it such that you are supposed to answer in terms of forces. If the question's science concept is about energy, then of course you answer in terms of energy. Is it about forces or energy? So I can see here, there's no mention about kinetic energy or movement anywhere here. Another clue here that tells you about forces is here, pull up the ramp. It's, I think, much harder to answer in terms of energy. Okay, it's much easier to answer in terms of forces. So concept, for example, here. So is it about forces? Yeah. So in short, I would suggest to you, you should answer this in terms of forces, not in terms of energy. So how I will answer this in terms of what the question requires is this. Alright, we are asked to explain what is the difference between the reading of the spring balance. Why is this figure smaller than this? Or why is this figure greater than this? So it's easier to explain in terms of forces. So these are two parts to make a complete answer. Alright, an object X is being pulled up the ramp. The pulling force has to be greater than the frictional force between the object and the ramp, and the gravitational force pulling the object down. So in other words, this pulling force as upwards has to be greater than two forces, frictional force and gravitational force combined. But when pulling it downwards, the pulling force needed to overcome the frictional force between X and the ramp is less, which is this figure, 300 grams. Why is it less? As gravitational force is also pulling X down. So there are two pulling forces pulling the same object down. Now, let's move on to the next one. So my answer in short is don't answer in energy because it is not relevant. The setup here shows light shining on two shapes. Notice that their dimensions are the same. When I say that, I mean, for example, the diameter is 5 cm and the height here is 5 cm. Therefore, the diameter here is also 5 cm. The breadth here is also 5 cm because this is a square. Okay, they should say square, but they didn't mention square, so I'm going to assume it's a square because it looks like a square to me. So they are basically the same size, right, in terms of height and width and breadth, but they are of different shapes. So then you place an A here and B here. So draw the shadow on the screen, and this is correct. So I don't have to discuss this. Obviously, the object that is nearer to the light source will cast a larger shadow. Alright, so whatever shadow B cast will be, well, part of it. You will not see a circular shadow because it's smaller than a rectangular shadow. And since B will not be blocking any light, because A has blocked the light, therefore you do not see any shadow of B at all. Now, explain your answer in A. So here you need to talk about what I just verbally said, right? So let's see how I would answer this question, and then we make reference to your answer. Okay, alright, I'm going to give you two answers for this, and before that, let's look at the concept the question is testing. So firstly, what's the concept? To cast a shadow, you've got to know that shadow is formed when light is blocked. That is one. The second concept you need to know is the object that is nearer to the light source, which is this object, will of course cast a larger shadow. So I have two ways of expressing my understanding of this question and why I only get a rectangular shadow, or a squarish shadow if you draw a rectangle, a squarish shadow and not a circular shadow at all. So the answer in the purple answer, okay? The shadow is formed when light is blocked. 0 mark here because it is a motherhood statement. A motherhood statement refers to just quoting a science concept. It's just saying this. There's no marks for this until you link it back to the question. So a shadow is formed when light is blocked. So what? And since B is in the shadow of A and won't block any light, no shadow of B is formed. Only that of A. So you see, I'm linking back to this idea. Shadow is formed when light is blocked. And since B won't block any light, no shadow of B is formed. Only that of A. Alright. Now, I can answer in a different way. I'm trying to give you two answers to see which is the one you understand better. The shadow is formed when light is blocked against the motherhood statement. So, no marks for this. 0 mark for this. And since A only blocks light, since only A blocks light, you see, this one blocks the light that comes out, and B does not have any light to block, the only shadow formed is that of object A. Right, so that's why I said only shadow formed is that of object A, the black square shadow. And that should be sufficient to answer this. Let's look at your answer. You said A is positioned closer to the torch than B. That's true, but that's 0 mark. True, but 0. Because you are stating an observation from this. Alright? You haven't linked to any science concept yet. You mentioned it's nearer, but they mentioned so what if it's nearer in terms of light and shadow. Hence, shape A will block more light from the torch than shape B. I wouldn't agree with this because shape A blocks all the light from the torch, not more, it's all of it. As you can see here, light can go past here, but all the light that shines in this direction will be blocked. B does not get any light to block at all. The light that goes above it, yes, there's light that go below it, but there's no light that go in front of it. So I do not agree that this is correct because A blocks all the light from the torch that shines towards it. So B doesn't have any light to block. Okay, so actually I wouldn't give this any mark. So this is how I would answer this. Either one of these would be fine. Always go back to the concept first. Now next one, study this setup below. Sarah switched on the fan, which is connected to the power source. So it's electrical energy. Converted the kinetic energy of the fan and the blades. Good. Convert the kinetic energy of the moving air, which is the wind. Convert the kinetic energy of the boat. That's very good. All this is correct. 1 mark. This shows the correct energy conversion. Now name the force. Now talk about force, so don't be confused. Huh? What's the force X? Now this is the one that's pulling downwards. So look at the arrow. Alright, and this must be your gravitational force. Correct as well. Next one. If Sarah increases the size of the sail, how would this be an advantage? Alright, so there are 2 marks for this. Now how will we give the 2 marks for this? Always go back first to the concept. What do you think is the concept? Alright, so to get these 2 marks right, you can answer in 2 different ways. In this case here, I would think you can answer in terms of forces or in terms of energy. Both are fine. So the first idea is you've got to know that a larger sail can catch more wind. Alright, so you talk about this, a sail has a greater exposed surface area to the wind, so more wind can act on the sail. So I would, if I mark your work, I will actually give this 1 mark here. But why? Because you've got to explain, right? So why does catching more wind help the boat? Or why is catching more wind an advantage? Now, in this case, there's nothing about racing the boat or making it move further or faster. So I'm going to assume, I have to assume because it's not stated in the question, I'm going to assume an advantage is moving faster, moving further. Those are 2 advantages I can think of. Alright, so what can make something move faster? Well, I can either answer from energy conversion. More KE from the wind means that there will be more KE in the boat. Therefore, the boat can move further and faster. I can give this and link to this idea. Or I can talk about this. More force from the wind, because there's more wind right now that's pushing on the sail. There's more pushing force, because you need a pushing force to move the boat. If there's no pushing force from the wind, the boat won't move. So when there's more pushing force, the boat will move further and move faster. This will also be another way to answer it. Right, so there are 2 ways you can use to answer. First 1 mark, then this is either this second 1 mark or this second 1 mark. So in your answer, you just mentioned it allows the boat to move further. You talk about the advantage, but I did not explain what allows the boat to move further. Is it there's more kinetic energy, or is it that there's more force? That link wasn't made. Alright? So that's why I think for this, you should only get 1 mark for this. Okay, next one. Alestia conducted an experiment to investigate the effect of a force on 2 different springs, A and B. He measured the length of the spring before and after a 10 gram load was placed on top of each spring. So if you draw a picture to help me understand, there's a spring and there's another spring, okay? And the original length of the spring was already different. A had if this were to be B and if this were to be A, the original length of A was twice that of B. The original length 4 cm, 2 cm. This will be my 4 cm, this is my 2 cm. And then a load was placed on top of the spring, 10 gram load. So I place a 10 gram load on top. So what happens? That will compress the spring. And notice that it both get compressed to the same degree. That means that spring B must be a stiffer spring. It's harder to compress a stiffer spring compared to this. This is a less stiff spring. Right? A is a less stiff spring, so it's easier to compress using the same amount, the same load. When we talk about compression of springs, I want to compare the differences between one compresses more than the other, the one that compresses more. So if you want to compress more, it is less stiff. If one compresses less, of course it must be stiffer spring. Okay, this is a less stiff spring. So I will agree with the choice here they talk about, right? That spring A is small. I will say I prefer using spring A is less stiff than spring B as the answer. Study the bottle which is used to dispense liquid soap. So there's clearly a spring inside. When the pump is being pushed down, the spring compresses and pushes air and liquid soap into the bottle. Right, into the bottle. Okay. Describe what happens when the pump is released. Now, interesting because you don't need to know the mechanism of this, and it's actually not so simple to describe. Alright, but if you have used any of such kind of liquid soap before and stuff, you need to experience to explain this. And when you use your experience, you know this does not happen. What do I mean? When you press down the nozzle, this liquid soap comes out. It happens at the same time. But the question here says it's happening in stages. When you press down, nothing comes out, but air and liquid soap enters the bottle, which is very strange. Alright, there's already liquid soap inside the bottle. So what does it mean by the spring compresses and pushes air and liquid soap into the bottle? This part here is already problematic. Question mark, question mark, question mark. Do you understand my question mark in my head right now? When the pump is being pushed down, presses this one down. Pushes air, okay, I can understand the air part. It's to go in to create a foam. Alright? But it says also pushes liquid soap into the bottle. But isn't liquid soap already inside the bottle? So the way it's described here, when you press it down, nothing comes out from the nozzle. So you're going to remove the hand from the pump before liquid soap comes out. It doesn't work that way. Do you agree with me? Let me know in the comments below whether you agree with this explanation of why this question doesn't work. Alright, because it's not a realistic one. I will actually ask this teacher if I have a chance, how does this work in your soap dispenser? Because it doesn't work in any of the soap dispensers I've ever used. Whenever I press down, soap will come out immediately at the same time, simultaneously. When I release, nothing comes out. Nothing comes out when I release my hand. Okay? So I do not know how to answer this question. So sorry. Okay, because it doesn't work. Now this is a past year PSLE question. So I can see from here, it's from the 2016, is it, paper that you took it from? So Jia Xian used the setup below to investigate the magnetic force between two magnets, alright? Explain why magnet A stay in the same position above magnet B. Alright, so of course it's a floating magnet, so the repulsion from the light poles between these two magnets is equals to the gravitational force pulling it down, so that allows it to stay in that position. Now, Jia Xian pushed the magnet A down towards B, alright? As shown in diagram 2, he found he need to push harder as this decrease. Why? Because the closer they are, the magnets are, the stronger the magnetic force of repulsion. Alright, yes, I agree with this. Now let's look at your question comes from point C, question C. A toy ball G floated above a base because of magnetic force as shown here. A second toy here has a rod through the center. Now, once you have a rod, right, there are surfaces in contact, so there will be frictional force at play here. Here, the only frictional force is between the ball and the air. Here, there's frictional force between the ball and the rod, and the ball and the base. So there are more frictional force here compared to this. It's just with the air. So he rotated both balls with the same amount of force, but H, right, will stop rotating earlier. So therefore, it should be answered in terms of your force. As I mentioned here, it is the same amount of force was used to spin these two. Why does this one stop spinning earlier? Well, force is used, the pushing force was used to spin this. Pushing force makes this thing move forward. So what will slow down and stop something? It is frictional force. Okay, it's frictional force. So the frictional force between H and the rod caused it to stop spinning. There's no comparison here. You are supposed to compare between these two. Why did this one stop earlier? So my answer is actually quite different from yours, and I'll answer it this way. I'll first talk about the frictional force that I can see here, which is between, the major one is between the ball and the rod and the base. And compared to this, the frictional force here is only between G and the layer of air surrounding it. So that, of course, H slows and stops first. So the comparison is here. The frictional force between H and all this, right, is greater than the frictional force between G and the air. So therefore, since there's a greater frictional force, well, it slows down and stops first. I think this is a complete answer, and this is not. Alright, because I don't see comparison here. You only talk about frictional force between H and the rod, but you didn't talk about frictional force between G and air. So why would this one stop? This is again a PSLE question. So you managed to get your hands on past year PSLE questions. That is from 2015 paper. The platform shows how diagram shows how a platform can move a man on a wheelchair up or down the staircase. Alright. Okay, all these forces description are correct here. The platform uses electrical energy to move. Alright. Now explain why the platform uses more electrical energy when you move the man up the stairs than when you move him down the stairs. Now I understand that you have difficulty doing this question, and I'm going to explain to you how to do this, and I'm going to explain to you why there's no need for you to do this. Now, this is not in your syllabus. This is a 2015 PSI booklet, so you're still following a 2008 science syllabus. Let me show you that science syllabus. Alright, so this is the 2008 primary school science syllabus. Now under the topic of energy, right? Under energy, what the students are supposed to learn under upper primary blue is the upper block. Is this idea about of work, right? Energy is required to make things work or move. Now what does work means? Work here is actually a scientific concept. Work is equal to force times distance traveled. So if we look at this one here, right? What is work? Now, work is said to be done when the force applied the object and move the object. There's a calculation for this, it's called work equals to force times distance traveled. And the units for work is in joule. Alright? And if you recall a lesson in the first couple of weeks of this year, we talk about joule as in the unit for energy. You see here? Joules is energy. So what does this mean? This also means that work has the same units as energy, joules. Energy used to do work, right? So you can say that actually energy is equals to the work done. So you must have energy to do work, right? So in other words, for us to move this one up, it travels a certain distance, force is required to move it. Let's go back to this again, formula again. It moves out a certain distance, a force is required, so work is done. So energy is required to do this work. Now, all this will sound foreign to you because this is what the pupils in 2015 and before they got to learn and do, but you no need to do all this. Alright, I show you right now for the syllabus that you're using right now. Also energy. If I look under this column for upper primary, P5, 6 is here onwards. Alright, there's no mention about energy is required to do work. Notice here, there's nothing about energy is required to do work. So such a question will not appear for you in your PSLE. Okay, so this is my assurance to you. Now, how about the next one? Well, I don't think you have issued the next one, right? Talk about it being rougher, so it actually will have more frictional force between those two surfaces. So this is definitely correct. So Halim found an animal in a stream deep in a forest. This is a past year PSLE MCQ question. Which of the following characteristics should he use to identify it as amphibian, fish, or reptile? Okay. Now what I've done is to just convert all this into a table form so it's easier for us to communicate with each other. And why gills? Because talk about option 1 is using gills to identify it as whether it is amphibian, or is it a fish, or is it a reptile, or is it body covering, or I use reproduction, or I use the habitat. Now, in order for me to identify it as one of the 3 categories, that characteristic used must be very distinctive. Alright, so definitely out will be reproduction because they all reproduce by eggs. Right, so this doesn't help me to tell whether it's a fish or amphibian or reptile because they all reproduce by eggs. So this is wrong, okay? Now, how about living on land and water? Well, I know amphibian lives on land and in water, but what if this animal doesn't live on land and water at these 2 places? Then it can either be fish or reptile, but I can't tell which one. Is it a fish or reptile? So I can rule out amphibian if I use this. Alright, if it happens not to be amphibian, but I can't tell whether it's a fish or reptile. So using this is not good enough for me to tell exactly which of the 3 it is. If I use gills and happen that this animal has gills, good, I'm very lucky, okay, it's a fish. But what if this animal doesn't have gills? Then it could either be amphibian or reptile, and therefore it is not good enough for me to narrow down into one of these 3 categories. This is also not good enough. The only one I can use is body covering, because if it has moist skin, then it definitely is an amphibian. If it has scales, it's definitely fish. And of course, it's in water, those scales are wet, right? If it's a reptile, right, it has dry, scaly skin. So these are quite 3 distinct things. So for me, I will use answer 2, type of body covering to differentiate this. Okay, if I see this, I know it's amphibian. If I see this, I know it's reptile. If I see this, I know it is fish. Now, Wonton sat on the right at an amusement park. So I see elastic rope. This tells me it's either about elastic spring force, elastic potential energy here. When released, the stretched. So you stretch it, therefore you are storing more EPE inside. There's more EPE in the stretch rope. Wonton, the stretch plus elastic rope pulled Wonton upwards. Okay, pulling upwards. As shown in diagram 1, the elastic rope stretched to a maximum length when he was at the highest point. Okay. So here is also being stretched. So then he will be pulled down by the elastic rope plus the gravitational force. Which one of the following correctly explains why Wonton was slowing down as he moved from P to Q? As he moved from P, this point, to this point Q, the rope was stretching. Stretching means that the rope wants to be pulled back to the original length. It's like you stretch a rubber band, alright? The more you stretch, the harder it is to stretch it because the rubber band just wants to return to its original length. So which one correctly explains that? So here for me, I would be using answer 3 as my answer. Elastic force, alright, which is in the stretch rubber band that as it stretches it, was increasing as he was moving upwards. Right, I'll choose this as the answer. I think this best explains it, because as it's moving upwards, what slows him down? There are a few things that can slow him down. Gravitational force can slow him down, but gravitational force acting on him is the same whether it's here or here, because his mass didn't change. Alright, it could be frictional force slowing him down, but the frictional force he has is against the air, and the same amount of air is here as in here. So it's not frictional force of the air. So it must be the elastic spring force from the rope. And that elastic force is pulling him backwards. The more he stretches this, the more the elastic rope pulls him in the opposite direction. It's like you pulling a rubber band. Okay? Now, number 3 is different. You ask what's the difference? Firstly, the difference is in terms of one is in energy, one is in force. Alright? And number 2 does not explain the slowing down. It talks about converting from one form to another, but it doesn't talk about slowing down. Okay? Now, moving and slowing is about kinetic energy. If you talk about kinetic energy becoming less and less, if Ke is decreasing, then that means that it is slowing down. But elastic potential energy is nothing about movement. GPE is nothing about movement. So there's nothing about slowing down in option 2. Next one. At the water theme park, 2 types of slides can be found. Serpentine, what a strange name, slides. Serpentine, oh, that is a shape of that. It's like a snake. A serpent is a snake, right? Serpentine slides take riders around a series of sharp curves, while speed slides plummet. This is a speed slide, okay, because these are all new terms to me. And you refer to the picture. So speed slide, plummet riders means it plunges them down really quickly, down a slide, and delivers them into a pool. Alright, so Alex is sliding down the serpentine slide. State 2 important properties of the material used for making a slide. Must be waterproof, must be strong. Very good, okay. I agree with both of this. Then Alex constructed a graph to show the effect of speed on kinetic energy possessed by a falling object. More speed, more Ke. Rather than, actually it should be more Ke, more speed. You want to speed up, you must have more Ke. This is the result of having more Ke. Okay? So when speed is 0, Ke is 0. Right, they are hand in hand. So based on the graph, what is the relationship between the speed and kinetic energy of object? As the speed increases, kinetic energy increases too, correct? At the end of the slide, the plunge depth was recorded. Okay. So plunge refers to how deep the person goes into the pool. Of course, the person goes down with more Ke, then of course it will go further into the pool. Notice here, this side of the pool is deeper, this side of the pool is not so deep. You can already infer that the amount of Ke here, alright, is less than the amount of Ke possessed by the person that going down this slide is more. So if it's more, of course you move further. To move further, you need more water, otherwise the person will just slam to the bottom of the pool, right? And that is not a pretty sight. So Alex took the speed slide and plunge that was also measured. The results are shown here. So the speed slide plunge in further. Serpentine slide, okay, less deep. Alright, plunge depth. Describe the energy change as Alex slide down the speed slide from the top. So look at your explanation. It seems correct. Gravitational potential energy is possessed by this person at the top of the slide. Good, they mentioned the source of the energy. As it moves down, the person starts to have more kinetic energy. The GP convert to Ke as it's sliding. Alright, sliding and moving person. So, okay, just say moving person will do. And then when the person hits the water, alright, it converts into sound energy, plunging in the pool. Heat energy. Is it, this is not due to air resistance. So I think here when it's sliding down, you are missing something. There should also be heat energy here. And this heat energy comes as a result of the person's bottom against the slide, the frictional force between the two. Alright, so there's actually heat energy between the between person and the slide. Alright, and when it hits the water, there's a frictional force now is between the person and water. Right, between person and water. Due to, I don't think it's air resistance, it's between due to friction between the person and water. Alright, that will cause this frictional force, right, between the person and water. So why was the plunge depth for the speed slide greater than for the serpentine slide? And this is how I will answer this for you. Right, the person going down the speed slide has more kinetic energy than the person going down the serpentine slide. This alone should give you that 1 mark. So of course it will move further. The plunge depth was greater. So all you can say, so the person moves further. Right? Remember I said so early on. This part here, there's more KE. Therefore, it goes further. Less KE, it doesn't go as far. Now, Alex observed both water slides and water flowing down the slide continuously. So, of course, it's a reduced friction between the slide and the person. Alright, that is okay. This is correct. Why? The purpose of a slide is you don't want the person to slide and then stop midway on the slide, right? Everything must have a purpose. So imagine this person stop here, and then another person starts to slide down. Then when the person crash into this person, so therefore, or the person gets stuck here on the slide because there's too much friction between the bottom and on the slide. Or this person is trying to play a fool and just want to stop in the middle and take selfie or something. The next person just comes sliding down and slam with this person. You do not want anyone to stop midway on the slide. So the person must continuously move down. You must ensure that happens. And to ensure that happens, you make sure that there is as little friction as possible. So for me, I would explain it in terms of that. So this is the first half mark that you should get. I think this is acceptable, but for me, I always link it back to the purpose. So the purpose of that, why? So people on the slide will move down continuously and not stop midway on the slide. That's how I'll explain this. It's like, why is the body of this pen transparent? And the reason is so I can see the amount of ink left inside, right? That is the reason for having this transparent. So if this part is not transparent, then of course, then this is not the purpose of choosing this material, which is also plastic, for this body. So it's a different function altogether. So here, why is this necessary? Talk about the function of why it wants the water there in the first place. So think about the function of the slide. You want to bring people down the slide. You don't want them to stay on the slide. So therefore, you must reduce friction. So the person will continuously move down the slide. Of course, your answer is acceptable as well, because another function of the slide is you want the person to move fast on the slide. So therefore, you want to have less friction. That's fine as well. So going back to this, so you can see that these are two different explanations for this. So I think yours work because it makes sense. I think mine work because it also makes sense. So this is how science is like. So long as you can justify your explanation, alright, your reason meaningfully and link it back to the science concept. Study the food web shown below. So let's find out where is a producer. So P definitely is a producer. This is your Plunge. Right, is a producer. Any more producers? We always start with producer. R is also a producer. Producer. How do I know these two are producers? Because producer is always eaten by. Arrow means eaten by. So A, for example, is eaten by B. So since R is not eating anything, P is not eating anything, these two must be plants. They make their own food. Alright, this is a herbivore, or this is a primary consumer. This one only eats plants. So this is my herbivore. This is my herbivore. Of course, for your case, you don't even know herbivore. What you learn is plant eater. Alright, for me, I use these terms because it's more concise, it's shorter. This is a carnivore. It's an animal eater. This is also a herbivore. It only eats plants. This is both a plant and animal eater. So this is an omnivore. This is a carnivore. This is my herbivore. So if population of R decreases, if this one decreases, that means immediately this one is most affected, right? I think everything will be affected, but firstly, let's take a look at this. This one depends on this for food. There's no other food source for organism T. There's no other food source. So this one definitely will drop because there's no other food source. So this is how I will see most affected. Whereas for you has two food sources. Oh, this one decreases. I have no food for, not enough food from this source, but I still can get from this. Okay? So this will also decrease, but not as much as T. So imagine if you only take vegetarian food, and there's just one store selling vegetarian food in the canteen. And one day the aunties selling vegetarian food happens to take one day off. You cannot eat from any other store. You will be very much affected because you don't have the source of food, the only source of food. Let's say for me, I can eat food from all the stores, whether it's a Muslim store selling Muslim food, or selling Chinese food, or selling vegetarian food. Even if the vegetarian store auntie doesn't come, I can still go to other stores. I'm less affected. So answer for this must be 3, okay? Must be 3. Yeah? I'm not sure which one is wrong, but it must be 3. Most affected. A praying mantis has several populations adaptation which help it to protect it from predators. So what are these structural adaptations? Structure means, okay, this is for your new topic that you learned just before the holiday started, right? So that refers to its physical characteristic, not the behavior, but physical. Okay, and you don't need to memorize any of these. There are only a few things in the text that give you ideas. So usually the picture given to you must help you to understand it better. So let's see if the description here makes sense. Alright, structural. So spreading foreleg is a behavior. It's like me putting my hands at my side if I'm very angry to make me look larger. So that is a behavior. Alright, I don't really look bigger. I'm not really bigger. It's just making me look bigger. It has feelers. Okay, fine. This is a structural adaptation. It fans its wing to appear more threatening. Does it have wings? It fans its wing. This is a behavior. It spreads foreleg. This is a behavior. It blends in the surrounding to hide from predators. So blend the surrounding. So its body must be of the same color or pattern as the surrounding. So D. Okay, so I agree with you. Answer is 1. Okay, question 28. The graph shows the amount of carbon dioxide in the air has changed over the years in the country from, this is a PSI question also, right? From 1970 to 2010. Okay, it has increased. Alright, CO2 level increased. So which are the effects shown in this above? But we haven't covered this yet. This will be taught in term 3 on man's impact on the environment. So when you have increased amount of carbon dioxide, then you have more carbon dioxide in the air. So what does that cause? Now, carbon dioxide is what we know as a greenhouse gas. A greenhouse gas will trap heat more. So that means that the more CO2 there is in our atmosphere, the more heat energy is trapped within our Earth's atmosphere, therefore increasing the temperature of the Earth. If the temperature of the Earth increases, alright, that causes to, for example, more ice, more glacier melting, more iceberg melting. Alright, CO2 in the air, alright, CO2 plus water will give you this thing called the carbonic acid. And carbonic acid is acid rain, right? That can damage buildings, especially those made of limestone, because carbonic acid can dissolve limestone. So it will cause acid rain. Okay, I don't think it causes soil erosion. I don't think it causes deforestation. All right. As I mentioned about melting of ice, that will cause melting of the iceberg and glacier. That will cause a rise in sea level, which will cause flooding near coastal areas. So this can happen. So A and B. Answer is 2. Okay. Now this one, some scientists claim that plants will glow in the dark when modified. Which part has been modified for investigation? Okay, Miss Ting, what is the concept being tested here? Glow in the dark. So in the dark means there's no light. So here means no light is present. Now this points to the nucleus. This points to the cell membrane. This is a cell wall. This is a cytoplasm. Now I can't link this to any science concept that you are required to know for plants. So I have no idea what is this about. My best guess will be nucleus. Alright, because nucleus control all the activities in the cell. So in the maybe when there's it can control activity as in glow in the dark. But I'm just making a guess, you know. Because it's not something that's really required for you to know. So I don't think it's a very fair question to ask. But I think this will be the best possible answer. Alright, because nucleus control the activities in the cell. Apparently here, one of the activities is controlling it is glowing in the dark. Okay? Which of these things is not transported by the human circulatory system? Transportation will be in our blood vessels through by the blood. Alright, water is being carried, digested food is being carried. Alright, carbon dioxide is being carried. Undigested food is not. Because if you recall from the human digestive system, this one will go past the small intestine to the large intestine and it will be expelled out from our body. Right, so number 4. Okay, now then release a tennis ball and a basketball each from the same height. So smaller ball, larger ball, I assume less mass, more mass. The tennis ball hit the ground and bounced a few times before stopping. He measured the height of the first rebound for each ball. Okay, the balls hit the ground, okay. Next, so you notice from the picture that the basketball seems to rebound higher. Alright, the first rebound. Next, he placed the tennis ball on top of the basketball as shown below, releasing them from the same height. Now this experiment, right, is from, you can search for physics girl. Okay, I'll try to find this link for you. He did an experiment to show this. Alright, and it's quite a cool experiment, and she did in slow motion. I think after you watch that video, you will understand better how this whole concept of all these things works. He observed the tennis ball bounce higher into the air than before. So, because, okay, I'll explain afterwards, okay? Heavier, more friction, question mark, I don't agree with the annotation here. Heavier talks about more gravitational force acting on it rather than more friction. Friction is between surfaces, direction of movement, and frictional force is opposing direction of movement. I think there's some problems with describing it this way. But I don't see the question. What's the question? I see this so far, but I don't see any question that requires an answer from you. Oh, here it is. Which of the following is the best explanation for the observation? What observation? Observation of the tennis ball bouncing higher. Now, previously here it bounces up. How? Here the GPE at first in the tennis ball, alright, converts to KE of the ball as it moves down and hits the ground, right? Tennis ball is hard, but if you try it, can you compress it? You can compress it slightly, alright? And that will actually convert into elastic potential energy, because when you press down the tennis ball lightly, you let go, it's like a spring, it's like you're compressing the tennis ball lightly. So there's some EPE inside here. They will cause it to bounce upwards and convert to KE, and it goes upwards. Of course, when you hit the ground, it also convert to heat energy, sound energy, okay? Then it will bounce upwards. That's for tennis ball. Notice this is a different kind of ball compared to, let's say, a ball that doesn't compress, like a bowling ball. For bowling ball, this will not happen, okay? This part. So if you drop a bowling ball on the bowling alley floor, it doesn't bounce up much, just a little bit. Now, what happens when the tennis ball is on top of this now? Now there are two balls being compressed. The basketball also get compressed when this hits the ground. Alright, now this is being rebounded up by the elastic potential energy in the basketball and the tennis ball. That's why now it bounces up higher. There's more EPE here now to move it up higher. Anything with friction is wrong. Huh? The gravitational potential energy of the basketball will convert to kinetic energy of tennis ball. No. The elastic potential energy of the compressed basketball, okay, as I just mentioned to you, right? When it hit the ground, it was converted to kinetic energy. Yeah, this is the answer. Because the basketball can be compressed. It's like you trying to shoot a catapult. You can stretch something and pull it. Yeah, best you see that video. That will explain this very well. And that's it. I hope this helped you. Take care.